Have you ever stopped to think about the physics happening with every single step you take? It's pretty amazing. Today, we're going to break down 4 really common physics terms that, let's be honest, can get a little confusing. And we're going to do it all using a simple story, just a walk to the market.
So let's set the scene. I want you to picture this. No labs, no complicated charts, nothing like that. Just you stepping out of your front door, heading off for a short walk to the local market. Simple, right?
All right, let's start our journey. To really get what's going on with the physics here, we have to be super clear about the exact path we're taking. We're going to break it down step by step.
Okay, so here's our route. From your house, you walk 30 meters straight down the block. Easy enough. Then you get to the corner, you hang a sharp left, and you walk another 40 meters. And just like that, you're at the market.
So here's the first question, and it seems pretty obvious, right? Your brain is probably already adding the numbers together. What's the total ground we covered?
And that simple question actually gets us to the heart of our first big idea in physics. It's this difference between the actual path you walked versus the straight line from where you started to where you ended up. Okay, first up is the term distance. Now, in physics, distance is exactly what you think it is. It's the grand total of the path you traveled. You add up every single step, every meter of the journey. So if we walked 30 meters and then we walked another 40 meters, our total distance is, you guessed it, 70 meters. Simple as that. This is the number your Fitbit would be bragging about. But here's where things get a little more interesting. Think about the path we took. It was kind of an L shape. Was that really the most direct route? I mean, if you could just fly there in a straight line, would it be shorter?
And that question brings us to our second term, displacement.
See, displacement doesn't care about the scenic route you took. It only cares about one thing, the straight line path, as the crow flies from your starting point to your final destination.
Now, to figure this out, you can see our path actually made a perfect right-angled triangle. And that means we can pull out something you might remember from math class, the Pythagorean theorem. A squared plus B squared equals C squared. So we take 30 squared, add it to 40 squared. That gives us 2,500, and the square root of that is our answer.
And there you have it. The displacement is only 50 meters.
Think about that for a second. You walked a total distance of 70 meters, but you only ended up 50 meters away from where you started.
Okay, so here's the crucial difference. Distance is what's called a scalar quantity. That just means it's a number, a magnitude, 70 meters. But displacement, that's a vector quantity. It has the number and a direction. So to be perfectly correct, our displacement is 50 meters to the northeast. All right, so we've nailed down the where and the how far. Now, let's add another layer to our little story. How fast did we do it? And for that, we need to bring in time. So to figure out how fast we were moving, we need to know how long the trip took. Let's just say, for the sake of our example, that the whole walk from our front door to the market took exactly 100 seconds.
And this brings us to our third term, speed. This is another one we use all the time in everyday life. It's just how fast you're going. And the calculation is simple. You take the total distance you traveled and divide it by the time it took. So for our walk, we take our total distance, that was 70 meters, and we divide it by our time, 100 seconds. That gives us an average speed of 0.7 meters per second. That's how fast we were cruising along that L-shaped path. But you probably saw this coming, right? If distance has its more specific physics twin, displacement, then speed must have one too. And it does. It's called velocity. Velocity isn't just about how fast you're moving, it's about how quickly your position is changing. And you calculate it using displacement, not distance. So let's put these two side by side. It makes perfect sense. Just like distance is a scalar, its partner, speed, is also a scalar. It's just a number. And just like displacement is a vector, velocity is also a vector. It needs a direction. So our velocity wasn't just 0.5 meters per second, it was 0.5 meters per second to the northeast. Okay, now for the grand finale. This is the part that's really going to make these ideas click. Let's think about the trip home. We're done at the market, and now we're walking back along the exact same path. So just think for a moment. We're doing the whole journey in reverse. What's that going to do to our total distance? And, more importantly, what is it going to do to our total displacement for the entire round trip? And here it is. This is the big aha moment. Our distance, well, it just doubles. 70 meters there, 70 meters back. That's 140 meters total. But look at our displacement for the whole trip. It's 0. Why? Because we ended up right back where we started. Your overall change in position is nothing.
And that right there is the single most important takeaway from all of this. The entire difference between these pairs of words boils down to one simple thing: direction. Distance and speed don't care about it, but for displacement and velocity, well, for them, direction is everything. So let's just put it all on one final cheat sheet. We've got 4 terms in 2 pairs. Distance and speed are our scalars. They're just the numbers. And displacement and velocity are our vectors. They're the numbers plus the direction. It's that simple little addition that makes a world of difference. So that's our deep dive. The next time you leave your house, whether you're going for a run or just driving to the store, maybe you'll think about it a little differently. Are you just counting the miles on your path, or are you thinking about that straight line back to where you began? It's a fun little thought experiment for any journey.